Morning, friends. Now we are going to continue the next part of the paper 2, that is a carbon dating. Carbon dating, that is used for the various application. So many applications are there for the carbon dating. Especially the three isotopes are there: carbon 12, carbon 13, and the carbon 14. Especially carbon 14 is not found on the earth. Atmosphere air contains carbon dioxide and also nitrogen. Cosmic rays mainly consist of this particularly atomic nuclei and protons coming from the interstellar space continuously interact with the nitrogen atoms present in the atmosphere. Atomic nuclei in cosmic ray disintegrate to produce the neutron, which further slow down at the lower atmosphere. Nitrogen nuclei, after capturing these neutrons, becomes a heavier isotopes of the nitrogen with their. Here the reaction has been shown. Nitrogen reacts with the neutron, then it will give the carbon 14 plus proton, and the proton picks up an electron from the atmosphere and becomes the hydrogen atom. The radioactive C14 decays with the half-life about 5760 years. This C614 combines with oxygen molecules in the atmosphere to form the carbon dioxide. All living beings use CO2 from the atmosphere for their growth. Thus, the carbon content in every living there must be therefore contains 614. This results in the concentration of C614 in Earth atmosphere remains constant with time. The concentration of C614 with respect to the stable C612 is also constant. As long as the living things are alive, the intake of the C614 balance the decay of C614. But when the living things dies, the intake of this C614 stops. Therefore, radioactive C612 content remains constant. The ratio of the C612 and C614 gives the time that had lapsed since the date of the plant or animal. Age determination can be done. C14 provides the radioactive clock. This come for the MCQ purpose. R0 is equal to rate of this particular ratio, and R is the rate of this in dead thing and the living things. Then you can calculate the age of this particular. T is equal to 2.306 3026 divided by lambda log to the base 10 R0 by R. Okay, this formula can be used. Radioactive isotopes and its application. Nuclei of an element having the same atomic number but a different mass number are called as the isotopes of the element that may come for the MCQ. Two types of the isotopes: stable and radioactivity. Stable isotopes do not show the radioactivity. For example, in 14 and 15, radioactive isotopes are chemically identical and with other isotopes of the same element but have ability to emit alpha beta particles or gamma rays. Some radioactive isotopes are K14, this cobalt 16, and iodine 313, etc. Applications of these radioactive isotopes: medicine, it can be used as a medicines. Iodine, that then the phosphorus, tantalum, then the iron, sodium, etc. are extensively used for diagnosing the functioning of the different organs of the body. Especially iodine is used in diagnosing of the function of the thyroid. Then tantalum is used to locate the brain tumor, bone, liver, spleen, lungs, kidney cancer, etc. Iron is investigated to investigate the blood disorders. Na is used to see the obstruction in the blood circulatory system. Gamma is emitted by the cobalt is used to treat the cancer of the different food and agricultural industry, archaeological. There are the different applications that you can see here. Okay. There are again the numerical based on this topic. Please go through this thing. Very simple things are there. If you are not getting anything, we can go or we can discuss it again. 1 curie is equal to dot 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 disintegration per second. Radioactivity is dot 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 nuclear disintegration. Okay. 1 curie is equal to 3.7 into 10 raised to 10 dps. Okay. That you have to remember. Larger the value of the decay constant, indicate dot 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 mean life of this particular thing, that is the equal mean life of this that is shorter mean life of the radioactive substance. Mean life period of radioactive substance is that times of the half life period or say radioactive substance, that is a 1.44 that we have seen. 1 becquerel is dot dot disintegration per second. 1 becquerel is equal to okay. This is about the different MCQs that may be there on this topic. Here the unit 1 of the physics 2 has been finished.